we are now ready to look at one of the most important things that we need to know how to do. And that will be factoring. Well, what does factoring mean? Let's have a quick look. We have seen so far what we do when we multiply polynomials. Let's say something of this form. 3x multiplied with 2x plus 4. What we do is we have used the distributive property and we said that 3x needs to be multiplied with the first term and with the second term. And we would end up with, one moment, what is this going to be equal to? 3x times 2x plus 3x times 4. And that would then be 3 times 2 is 6, x times x is x squared, plus 12, oops, I'm running out of space here, 12x. So, from this to this is called multiplication, and we are now basically doing the exact same thing, just reversely, and that is going to be called factoring. I'm turning something with addition into the multiplication of two factors, the product of two factors. So the first method that we are going to be using is called the greatest common factor, or short, the GCF. The greatest common factor is an expression of the highest degree that divides each term of the polynomial. We are going to see in just a second with some examples what this really is going to look like. The variable part of the GCF is always containing the smallest power of the expressions that appear overall. So let's go ahead and have a look. We want to find the GCF of the following monomials: 18x cubed and 15x squared. So we have just said a second ago that it would be the expression that divides both of these monomials, and the variable part is the one that is of the smallest exponent, the smallest degree. And the smallest degree that we see right here is A2. So our GCF contains out of x squared. Then I'm going to be looking at my numbers 15 and 18, and both of these are divisible by 3 at the most. So the GCF will be 3x squared. And I can visualize this by saying that, one moment, 18x cubed, this can be rewritten as 3x squared times 6x. If you think that this is magic, let me just show you really quickly how we got this. We said that the GCF is the one expression that divides this. And if I say 18x cubed divided by 3x squared, this divides in nicely. 18 divided by 3, that is going to be 6. And x squared divided by x cubed, divided into x cubed, is just going to be 6x. So from an example earlier, when we were checking polynomial division, we said that if we have something like this, let me make my 8 a little bit nicer, that 18x cubed divided by 3x squared is equal to 6x. This is something that we have done earlier. We could always check this by multiplying both sides with 3x squared. So in other words, I would get this. I multiply this by 3x squared. On the left side, the 3x squared would cancel out, and I get this expression. This is just what we are going to be using right now. So if I do the same thing with 15x squared, then I can take 15x squared and I can rewrite this as 3x squared multiplied by 5. And we see 3x squared is the greatest common factor that both of these expressions had, these two right here. All right, let's do another example. Now, let's find actually out how we are going to use this. Factoring a monomial from a polynomial. The first thing that we're going to do is we're going to determine the GCF. Secondly, we're going to express each term as the product of the GCF and the other factor. And then lastly, we're going to use the distributive property to factor out the GCF. Or in other words, we're going to pull the GCF out. Here is our example. 7x squared plus 28x, and we are supposed to factor this. These are two terms. I'm going to look at 7x squared and 28x, and I notice the first thing that I'm going to do is I'm just focusing on the numbers, 7 and 28. Both have a factor of 7 in them. Both are divisible by 7. And the smallest exponent that I see is an x to the first. So the GCF is 7x. Now I'm going to express my 7x squared into 7x times x plus 7x times 4. Again, what we are really doing is I'm taking this and I divide this by 7x and I divide this by 7x. And what is it that I'm going to be left with? In the first expression, I'm going to be left with an x. Here, I'm going to be left with a 4. So now what we're going to be doing, I'm pulling out the 7x. I'm using the distributive property backwards. I am pulling the 7x out of my first term. I am left with the x. And if I pull out the positive 7x out of my second term, I'm left with a positive 4. And we are done. I can always check this by multiplying it back out again. 7x times x is 7x squared. And 7x times 4 is 28x. Let's do one more that looks a little bit different. 6x squared plus 18, and we're supposed to factor this. I first have to find a GCF. So I'm looking at my two terms, 6x squared and 18, and I'm first only looking at the numbers 6 and 18, and these both are divisible by 6. Now, there is no x in my second term, and that means the GCF is just 6. So I take 6x squared, and I rewrite it as 6 times x squared. I divide this first part by 6 to get the x squared. I divide the second part also by 6, and what do I get? 3. Now I'm pulling out the 6 out of both terms, and I'm just writing down what I'm left with, the x squared plus 3. And we have factored 6x squared plus 18. Let's have a look now at something that is a little bit longer than the problems from before. In this case, I have 3 terms. I am asking myself the same thing again. What expression is dividing each of those of the highest degree? That means the biggest exponent that divides in all of those, which is the smallest number that you see. And x to the third would go into all of those evenly. Then I look at my numbers 15, 12, and 27, and I notice that all of these numbers are divisible by 3. All right, that means that the GCF now is 3x cubed. Now, if I want to write this now again, just like in the examples from before, always as 3x cubed times something plus 3x cubed times something minus 3x cubed times something, then all I have to do is I look up here, and I just divide 15x to the fifth by 3x cubed. 15 divided by 3, that is 5. And x to the fifth divided by x to the third, that is an x to the second. Notice that when I would multiply these two out again, I would get 15x to the fifth. So what will I get here? 3x cubed times 12 divided by 3, that is 4. X to the fourth divided by x to the third, that is just an x. Negative 27 divided by 3. The negative we have placed on the outside right here. 27 divided by 3, that is 9. X cubed divided by x cubed is just 1, so the x's are completely canceling out. Let's visualize what we have. We have a 3x cubed in each term, and this is the one that we are going to pull out right now. Out of all of these terms, I'm going to have that this whole expression is the same thing as what is left. I'm just collecting my 5x squared plus 4x minus 9. Oops, that needs to go a little bit closer.